So right now what we're going to do is convert back and forth between logarithmic and exponential equations. Key thing to remember, if you have an equation of the form b to the x equals y, it can be rewritten as a logarithm as x equals log base b of y. Make sure that the base in the logarithm is written as a subscript. Don't have it floating. So in our first one, 8 squared equals 64. The base of the exponential equation is 8, which makes the base of the logarithmic equation also 8. The exponent is 2, and that's our x in our equation in purple off to the left there. So we could say 2 is equal to log base 8 of 64. So it's a matter of putting things in the right place. And if you want to put the log on the left-hand side and write log base 8 of 64 equals 2, that's perfectly fine. For the second one, what's the base of the log? 9. Great. So that makes the base of the exponent also 9. 9 to what power? The 1/2 power equals 3. So 9 to the 1/2 equals 3. Remember, we can check this because a 1/2 exponent says take the square root. The square root of 9 is 3. Checks out. The third one is a special case. When your base is e, it turns into what is called a natural logarithm. We do not write the subscript of e. So this would become the natural log of 23 equals the exponent x plus 2. So going from left to right here is a good idea because if the directions were to say write as a logarithm, we now could solve for x by subtracting 2. I'm sorry, if the directions were to say solve for x. Sorry, didn't have my coffee yet. It's downstairs still. So again, natural log is written ln. Do not write a subscript because it's implied. When you see log with no subscript, we assume that the base is 10. So the base of the exponent is the base of the log. So since the base is 10, we'll say 10 to what power? The 4th power equals the argument 10,000. And you can check that as well. 10 to the 4th does equal 10,000.